Hey guys, welcome back to another Math Exponential video. Today we're going to go over the 12 basic functions in calculus that you'll need to know, and sort of some tips and tricks for figuring out which function you're looking at and things like that. So we'll begin with sort of the basic functions that you probably already know, like the line here. This is going to be your first function out of 12, and that's basically just f of x equals x, or y equals x. And this is a nice graphic here you can find online, but I have it here too. And basically, you need to know is a line is a line, and it has a slope. It has a domain of infinite x and infinite, and then a range of infinite y. And so you probably all know what a line is, but that's one of your 12 basic functions we'll be working with. The next one is going to be your quadratic, or your squaring function, which is, you probably already worked with this in pre-calculus too, but it's going to be y equals x squared, or f of x equals x squared. It's going to have an infinite domain, but in this example, which these are just the basic rudimentary functions, because later on, you've probably done this in pre-calculus too, is we'll be working with these 12 basic functions and manipulating them, figuring out how to move them around in the graph, stretch and compress them. But those will be in later videos. But this is kind of the rudimentary what it looks like. And for this particular quadratic, it has a range of from 0 to positive infinity. And then you have the cubing function, the cubic, which is going to be y equals x to the third. And this is similar to the x equals, so all the other, or to the, a line and a quadratic, that is x to the 3. Also, I want you to know that this on this side goes to negative infinity, and this side goes to positive infinity, whereas a quadratic, both of them go to positive, and a line is similar to a cubic in that both of the, and that the to the left is going to negative infinity, and to the right is going positive infinity. So that's something also remember to take a look at. And similar to the line, it has a domain of positive infinity or negative infinity to positive infinity, and a range of negative infinity to positive infinity. So those are the first three. Now here's number 4. Going to be your absolute value, which is basically if you take the line and take all the negative values and put them positive. So it's going to sort of look like a V, with the, a point right here, and we'll talk about that later, and what that point sort of represents when you start doing limits. But an absolute value is going to be usually written as f of x equals, with these two lines next to that, with the x in between. So you probably worked with absolute values before, but you're going to be dealing with a lot of absolute values, graphing them and moving them like other functions. So that's kind of a different aspect to absolute value. This is what the graph looks like. It's similar to the quadratic. You can have positive and positive, or it's going to positive infinity on both sides, and the domain range are very similar to the quadratic. So this is starting where we're going to get into functions that you may not be familiar with. So number 5 here is the reciprocal function, and it's basically going to be 1 over x. And so it kind of looks strange, and this you'll be working with this a lot, or we'll be working with this a lot in the future. But it's just y equals 1 over x, and that sort of changes the graph a lot. So you have something called a asymptote right here, which is basically means that this part of the graph and this part of the graph go to infinity as close as possible to that imaginary line, but never touch it. So they never cross the y-axis. They go infinitely close to it, and they go infinitely high in either direction, but they never touch it. Also, there's an asymptote right here too. We'll discuss that a little bit later. You may discuss it in pre-calculus, but the graph becomes infinitely close to this line, but it never crosses or never touches it. So So those go on either side as far to the right and left as possible. And with this fancy U here, you may have not covered it, but this is just interval notation, and it says that in the main. It goes up to 0, it never touches 0, and then it goes to the same on the other side. And same with the range. All right, so there's number 5. There's number 6. This is a square root function, and basically it doesn't have any values that are less than 0. So the domain goes up to 0, includes 0, but doesn't have any values that are less than 0, and it sort of just goes like that. Yep. And basically, what you'll need to know is, of course, well, the reason why there's no domain that's less than 0 is because if you have a negative under the radical, I mean, then it's undefined. So the function's not defined when it has a negative number. It's only defined when it's positive. So that's why it's like that. And then the next one is going to be your exponential growth, which this one's represented by an e to the x, which you'll see that more than not. But you can also have like 2 to the x, and that would also be called an exponential growth function. And we'll also discuss more detail on the movements of functions and how they actually, how this function can be moved to the up, down, can grow faster, grow slower, stuff like that. But the important thing is that there's an asymptote right here that it infinitely goes close to, and it goes infinitely high here. This is different from exponential decay, which is basically this graph is flipped across the y-axis. We'll cover that when we cover how we can manipulate exponential growth functions. But this is basically how an exponential growth function will work. Now this is probably the first time you've seen it, but this is called a logistics function, basic logistics function. And there's 2 asymptotes, one at this upper limit and one at this lower limit. And the max slope is right here. This is kind of important in a lot of word problems. This is you'll mostly see this in word problems. This is max slope. And that's in between the 2 asymptotes, but it goes infinitely close to this one on this side and infinitely close to that one on this side. And this is sort of what it looks like. Don't be scared. We'll just dissect what this means later. But this is sort of the form you'll see the function in, how it becomes close to one asymptote on the left and close to the other on the right. This models populations very well. All right, so what are we on, 9? Number 9 is the natural logistic function. This is basically the same thing, or it looks very similar to our square root function, but it is different. And the main difference is it does have an infinite range, meaning that this goes infinitely low, and the square root stops at 0 for the range. But it does look similar, but you gotta remember that passes through 1. It always passes through 1. Also, on the exponential growth, it always passes through 1 here. But it passes through 1, natural logistics function, and it goes infinite range, negative and positive. Okay. Number 10. Greatest integer function. You may have seen this, and you won't touch it very much in calculus, but it is very useful to know. And basically, it's actually very useful in programming too. But basically, it takes all the values. You can almost imagine this is sort of like a line here. But it takes all the values like in between, so like 0.5, and brings them down to the next lowest integer, or floors it. So if you're familiar with programming, it'll floor the value to 0. So 0.5, like if you put x as 0.5, the answer will equal to 0. 0. So we'll floor everything, so the graph will sort of look like this. It's kind of unique, and we'll touch on it a little bit, but not as much as the other functions, but it's definitely something you need to know. And then the last 2 are you'll be dealing with a lot throughout calculus, and this is your sine and cosine functions. I'll touch them together here in this video, but we'll dissect them individually later. Basically, they have the same domain in the range, but it's one graph shifted over exactly 2 pi. So this is yeah, pi over 2. Actually, it's shifted over, not 2 pi, sorry. Pi over 2, it's shifted. And so sine, starts at 0, 0, and goes up to 1, then back down to 0, negative 1, and 0. So in pre-calculus, you touched on the unit circle a lot. So this is basically a graphical representation of the unit circle. This is pi, and this is 2 pi. So, and then cosine is just going to be shifted over. So it starts at 1, then goes down to 0, negative 1, 0, and it's just shifted over 1. We'll touch more on how this sort of plays out, but basically it's just represented by sine of x. Sort of similar how to greatest integers is int x is just sine x, and you know that the sine curve or the basic sine curve looks like this, and then you manipulate it later. But this is the sine curve, this is cosine curve, and that's how you can visually represent the actual unit circle, which is kind of cool.